Good morning and good afternoon, and welcome to Microsoft Learn Live. Today, we will be presenting modern data warehouses, designing, building, and operating, presented by Fast Track for Azure. My name is Ben Harding. I'm a data engineer in the Fast Track for Azure team, based in currently freezing cold Canberra, Australia. Nitin, do you want to
My name
introduce yourself?
is my name is Nitin Mehta, part of the same team. I'm based out of New Delhi, India, and focus on data platform.
Wonderful, thank you. If you could just jump to the next slide, and I'd just like to introduce our moderators and also my colleagues. They're also part of the Fast Track for Azure team. Osamu Hirayama, Miho Yamamoto, who are both based in Japan, and also Ryan Krokow, based in New Zealand. So we like to run these sessions as interactively as possible. And although you can't come off mute, you do have access to the chat where our moderators are ready to answer all of your questions. So next slide, thanks, Nitin. My team, Fast Track for Azure, is a customer-facing engineering group dedicated to working with organizations on their migrations into Azure, as well as new solutions. We're not sales, we're not marketing, so we bring with us real-world technical experience after working with hundreds of customers across the globe. We've partnered with Microsoft Learn and developed an official Learn collection on this topic. And Nitin will talk you through this content towards the end of today's session. But I strongly encourage you to grab that link on your screen now and keep it as a reference for future. Also, if you do navigate to that link, okay, and you look at the second item, okay, it's going to take you to a GitHub repo, and that actually has all the content that we are going to be covering in this session today. So feel free to, like I said, go into that collection and access that GitHub link, and you can actually follow along, jump ahead, whatever. But yeah, I hope you save it and bookmark it. So if you just want to go to the next slide, thanks, Nitin. We should see our learning objectives here. So today we want to, our objectives are to understand what a modern data warehouse is and the steps required to take that high-level concept to a solution in Azure. Number two, it's going to learn where you need to focus when embarking on your modern data warehouse solution and the key decision points that can unblock and accelerate your project. And number three is discover the best practices for operating and maintaining a modern data warehouse. So we have a huge amount of content to cover in this. And in fact, we actually have too much content, but we've done that on purpose. So during this session, we're going to walk you through and focus on the important aspects and bring in the real world context of how other organizations have been building these that we've been working with. The reason why we wanted to have so much content is that we want to leave you with the official collection, okay, as well as that GitHub repo I just mentioned, which we will continue to maintain and continue to deliver this session. So it's just going to be always up to date. Also, don't forget to complete this survey. So we're going to flash up that link a couple of times. It's going to be available in your in the chat as well. We really do listen, and we do really care about every single response, and we take all feedback on. So let's finish with the slide deck and jump across into the content, and don't forget to ask those questions. So I think my producer is going to share my screen here, and we should hopefully see my collection. Just quickly double check that everything's going okay. So this is the collection, and like I said, Nitin's going to talk you through this in a bit of time. But what we're going to use really for the majority of this session is this second link here, okay? We're just going to take you to this GitHub repo, okay? So this is, like I said, this is what we're mainly going to use. So let's jump into the introduction. So when we were putting this together, we really wanted to set a baseline of what it is we're talking about. Like, what is a modern data warehouse? What is a data warehouse? And the interesting thing is, there's actually a lot of definitions, and there's no one clear answer about what a modern data warehouse is. So let's just start with a baseline of what we're talking about. A data warehouse, okay, that's a central repositories of integrated data from one or more disparate sources. They store current and historical data in one single place that are used for creating analytical reports for workers throughout the enterprise. And that's from Wikipedia. And this is Microsoft's definition of what a modern data warehouse is, which is it lets you bring together all your data at any scale easily and to get insights through analytical dashboards, operational reports, or advanced analytics for all your users. So to me, those definitions are actually pretty similar. And there's some subtle differences between them, which we're going to go through. So why build a modern data warehouse? Okay. Well, the first point is you want to build one to support modern business requirements and scenarios. So where a traditional data warehouse often set up to support, say, maybe like batch-driven ingestion, overnight ETL, and then presenting the reports based on yesterday's data. Organizations generally want to move faster and want to be able to, say, report on not just the sales figures from yesterday, but what happened the last 2 hours, the last hour, the last 30 minutes, the last 5 minutes. And so that is what's driving these new platforms. Also, modern data warehouses support data-driven decision-making within organizations, similar to a data warehouse, but I guess with more of a modern tilt. A modern data warehouse is far better suited for advanced analytic workloads, such as AI and ML. Modern data warehouses support data exploration and discovery. And you may have heard the word data democratization before. To me, that means about giving access to as much data within your organization as you can, within obviously security and other guidelines, and basically putting it out there so let every business unit and every individual make decisions based on data. And the final point for why to build a modern data warehouse is cost efficiency. So if you were to build a modern data warehouse on Azure, some of the core components and services that you deploy basically, when you deploy them, like say a storage account, have no cost or very minimal cost. And so it's basically a consumption-based charging. So as you start using it, the cost goes up. But as you deploy it into your environment, generally very cost efficient. So what makes a data warehouse modern? Okay, so we talked about what it is, a modern data warehouse, why you want to build one, what makes it modern. Just want to quickly go through this table, okay, and compare like a traditional data warehouse with a modern data warehouse. So a traditional data warehouse, okay, is it ingests data from multiple data sources and it's usually structured. And I should have called out before, but I'm going to intentionally use vague terms here because not every data warehouse is created the same, and same with modern data warehouses, but just in general, based on our experience with customers. Okay, so a modern data warehouse, you ingest data from multiple sources, but key difference here is of different types, okay, which means structured, semi-structured, unstructured, and or streaming. A data warehouse is usually based on Kimball or Inmon or Data Vault methodologies, and you store it in a relational database engine. A modern data warehouse supports big data, and the data is stored in a data lake in general. A data warehouse is usually batch loaded. A modern data warehouse, I would say usually is batch loaded, but as well as using micro batch, near real time ETL or ELT. A data warehouse, you generally bring it into a database, which means you need to have a defined schema, which means you need to define a model and relationships. That can all take time. So it can take quite a bit of time to get insights out of your data. Whereas a modern data warehouse, combined with the, I guess, modern processes of building it, you can gain access to insights faster. Okay, a data warehouse is often built on enterprise relational database engines, modern data warehouse on highly scalable and modern technologies such as like Azure Data Lake Storage Gen 2 and Spark. Data warehouse, you can normally scale up, okay? A modern data warehouse generally scale out. A data warehouse usually can be built on-prem or in the cloud, no problem. A modern data warehouse, I would argue, can only be built on the cloud. There might be some really large organizations out there that that have got the scale to build something like this on-prem, but I'd argue strongly that modern data warehouses are really intrinsic to being built on the cloud. So that's our introduction. Nitin, over to you if you want to kick us off and get into start the real meat of this content, which is how to design one.
Now, Lauren, can we get back to my screen, please? All right. So yeah, Ben spoke about, gave an introduction to modern data warehouses. What makes it different from your traditional data warehouse, right? Now, obviously, next step in that journey when you decide to look at modern data warehousing is how you're going to design it, right? Because to be able to build it, and it's very important because when you want to build a modern data warehouse, it's a little bit different from the traditional data warehouses where, as Ben spoke about, a lot of things needed to be put in place before you can actually get started. uh, you need to know exactly where your data is coming from, exactly what kind of transformation you're going to do, who's going to consume the data, and number of other things including schema, right? Now, designing a modern data warehouse requires you to get an understanding first, and understanding of the concepts that are going to play uh, in designing this modern data warehouse, as well as understand that there is a lot of help available, right? So for example, if I click on this first link, which is to Azure Architecture Center, you can actually uh, explore a lot of architectures, architecture documents that are available across industries. So it's highly likely that the industry or the use case that you're trying to solve is already covered by some of these architecture diagrams. So that's one. And another part is the architecture itself. So Ben spoke about the velocity and variety of data that's coming in, right? You want to uh, probably look at the data which is just 5 minutes old in your system, right? Which means a couple of important factors that come into place. Uh, if I look at this one architecture diagram and take you through this, oh, my bad. I'm sorry. This is not supposed to happen. Okay, let me stick to this any case. Um, so if you open this, what I'm really trying to say is few things here. One, obviously you have help with a lot of architecture uh, documents being available, but look at this sample architecture diagram, right? Um, of course, you had pipelines that would do data transformation even in traditional data warehouses, but you'll hear more about ELT instead of ETL when you talk about modern data warehousing. What that means is you start with designing pipelines in such a way, usually, that you would load and uh, store the data first before you start transforming it, right? and that means a lot more components come into picture, and we'll talk about those. We'll talk about data lakes and why you need to understand the concept of data lakes. Um, and basically what I'm trying to say is that the architecture changes slightly. How you store the data afterwards, how you use different methodologies, different technologies to transform that data before you before the data is available for different business functions to consume it. Another point that I want to drive through this same diagram is, while it is good to have this architecture diagram that helps you, it's also important to understand and make sure that you're putting in place services which make sense to your environment today, right? For example, if I look at this particular diagram, it also has a streaming ingestion component, right? In addition to your batch or micro batch ingestion, which happens through pipelines. Now, you might say that, yes, I'm expecting, some kind of streaming mechanism down the line, maybe 12 months down the line. But do you really start with that? I think the answer is no. The idea is, and if I can go back to our document, the idea is you keep it iterative, you make it modular, so that the design that you come up with is is in line with your immediate goals, and also you have an understanding that it is modular, which means tomorrow you might add many more sources of data, and that's fine. The sources of data might bring in the data in a different format, which is perfectly fine. So the idea is, keep it simple, keep it iterative, start with a lot of help that is available out there. um, Next, there are frameworks that you can, that you should, and we strongly recommend that you sort of bake uh, in your architecture. So if you talk about cloud adoption framework, for example, it does talk about a lot of things that you want to put in place, right? uh, it talks, this particular cloud adoption framework is specific to cloud scale analytics, which is what we are focusing on now. But the idea is, that governance, that how will you allow the data to be consumed, how will you support it, how will you, you know not just support it, it also gives you reference into how you can deploy it quickly. So if any of these implementation templates work for you for your environment, it's rather easy to simply deploy it right out of this, right? So what I'm trying to say again is that you start with putting a framework in place and know that there is a lot of help available through which you can quickly deploy. Again, back of your mind, you know that it is iterative process. You are going to, I mean, don't hesitate in going back to drawing board, right? Do that as often as required. um, and there are common data models which are available. If there is one for the industry that you are in, it may be a good idea to just, have a view of that. Maybe you want to put that schema in place, and this is not schema which, you'll ingest data in. This is something that will help you see the data when you want to explore it, or when you want to expose it to the consumers, and they'll be able to see value in your data. So there is this common data model available for different industries that you may want to refer to while you are building this architecture, while you're designing your modern data warehouse, right? Not necessarily in the same order, but uh, designing is, once you have an understanding of what you are going to do, designing that um architecture, or putting that in white and black, is really important. You start with, high level design, which should which should define the requirements that it is trying to serve, right? So, like I said, not necessarily in the same order, but requirements are the driving factor here. Ben spoke about the velocity, the kind of data that's coming in, and that's where you start with modern requirements, right? Um, Idea really is that you don't start with boiling the ocean. Don't try to replace if you have an existing data warehouse with a modern data warehouse. You know, keep keep your eyes on the timelines, on the modern requirements, and start with that, knowing that it is a modular design. A lot of times what we see in our experience with customers is that, you know, starting with a generic data platform requirement, as in, you hear about some buzzwords, you hear about lake houses, you hear about Spark, and you know you think that, okay, let's build that data platform. But that's where that modern requirements piece comes into picture, right? It's very, very important. We cannot stress enough, because if you are building a data warehouse or the data lake um, without specific timelines, without specific and modern requirements guiding you to get there, it becomes very difficult to ensure that what you have is actually a modern data warehouse and not a data swamp. um, Another part, so I said start with a high level design which talks about the requirements that you are trying to solve, which should which sometimes talks about services that you are going to use. Sometimes it's just you know uh, high level block boxes which say you know the data is going to be ingested in batches, and then you're going to store it in some space and format. um, but after you have had that design, and I know I'm reiterating, but I cannot stress enough, that it's going to be a modular design. It's an iterative process, right? So once you have that high level design in place, you I think the next step would be to have a look at well architected framework, what that gives you, and you have all these links available as part of I think the link that's been shared already. uh, what that gives you is an understanding of all the pillars that you can start asking yourself, right? When it comes to requirements, what kind of reliability requirement and security requirements do you have? Do you want to build for uh, certain maybe RTO, RPO that business might have in mind, right? So start with a well architected framework, gives you a guidance on how to build that in an effective way. And then once you have all of that captured, it's again, equally, if not more important, that you actually come up with a physical design. I think you would agree, and Ben, if you want to add this, but I think physical design is very important before you can actually start deploying your environment,
Of course, yeah.
right? So physical design is going to tell all the stakeholders exactly what you will have in place, right? How will it connect to, for example, your data sources, what kind of networking requirements you have, subscriptions, how you're going to manage them, where are you going to deploy your resources across subscriptions, across regions, across resource groups, um, and becomes very specific to services that we are, you know, now putting in place to build this modern data warehouse. So
Yeah.
the
And,
logical next
it-
step.
it- and a physical design also enables you to communicate with other people better as well. So if you are trying to if you produce a high level design, and I've seen dozens and dozens of them, um, and and people present it to me and say, okay, this is what we're going to build. It's it's just like, okay, that's great, but what is it going to actually look like if I was going to log into your Azure portal? Like, in what subscription, what region, what resource group, what's your networking setup? High-level designs do not capture that in general, and that's where I see customers getting stuck, going from that point from a high-level design, and often using one of our reference architectures, so that's great, but getting to a point to say, well, this is actually what it's going to look like in our environment. So that's a real key takeaway, is to focus on getting that detailed design with pencil onto paper. And I say pencil because you might want to come back and change it. But that's definitely where I see customers kind of fall short sometimes, and then can actually impact the delivery of the project.
Yeah, it really helps, bringing out that complexity that you are going to see when you actually put that in deployment, right? So if you have that design, you come across complexity, you come across how, you devise ways to make it easier. You understand all your stakeholders that are going to come into picture and, help you build that. So it is important. Yeah. Next, I already spoke about requirements, but we still have, separate section on it. And the reason is, you know, again, we cannot stress enough how important this is, how important it is to gather your business requirements, convert them into functional, non-functional requirements. And those requirements, if you start with the right requirements, also tell you the timelines, also tell you, uh, also have an effect, a large uh, effect on the design that you'll come up with. So again, like Ben spoke about the physical design part, it's equally important for requirements to be captured maybe with a pen pencil, to ensure that your stakeholders are in sync. You know what you are trying to build, and it's not just a generic data platform which should, solve all your problems, because there's no such thing, right? Now, having spoken about that, the concepts that really, play in when you're trying to build a modern data warehouse, we strongly recommend that you take a look at data lakes. This is a concept that uh, really, Ben was talking about warehouses, data warehouses, and modern data warehouses. So one of the pieces that really differentiates a traditional data warehouse from modern data warehouse is the concept of data lakes, right? Um, the reason you did certain things with modern data warehouses in certain way was because, you know let's be candid. It was costly to store all that data in a traditional data warehouse. So storage was, you know tightly coupled with how you uh, scale up that data warehouse. But with the uh, introduction of data lakes and making sure that you actually understand the concept of data lakes, gives you that freedom, as in how the data gets ingested into your data platform. And then, you have several ways you can process this before it becomes consumable, right? And do understand that your consumers could be, five different groups altogether. So in a traditional data warehouse, your consumer, the biggest consumer was business. Now, one of very important group of consumers of your modern data warehouse or a data lake environment is also your data science team, which means that you need to make data available in certain form, which allows them to do all that uh, really, advanced analytics on the data as it comes in. Um, Also, it's important to understand that there is a service called Azure Data Lake Storage, ADLS Gen 2. But as a concept, data lakes are kind of beyond what ADLS does, right? It's kind of like saying, is your platform compliant with certain requirement? Yes, the platform is compliant, but have you made sure that you pull all those levers, you put all those, you know, security standards in place which will make it compliant? So making use of the features which are available in ADLS Gen 2, or features which are available outside of ADLS Gen 2, and across Synapse Analytics as a modern data warehousing uh, platform. It's important to understand the concepts so you can make right use of those features. Um, wouldn't you agree, Ben? I mean, in our
Yeah, yeah.
experience, right?
And I think
In our
that's
experience, sorry.
yeah, and so like I mean the data lake, this data lake concept that we're talking about is really it's like the first kind of part of a modern data warehouse that we've spoken about with kind of 30 minutes in. So, and the reason we wanted to call this out so early is that it really is like part of, in my opinion, every modern data warehouse. Um, and it's going to be one of the first things that you come up, you're going to, I guess, run into when building it. So as soon as you say, okay, I want to get data from a source system and ingest it, okay, and generally land that into a data lake, as soon as that first bit of data arrives, you're going to have really have thought about what is a data lake. What does it look like in our organization? Um, what's the kind of governance around it? What's the requirements on it? So things like, do I need to back up that data now that I've landed it? Does it need to have DR, high availability? And I just lost what I was going to say, but it's yeah, basically the first thing you're going to run into. Oh, that's right, things like folder structure as well. So as soon as you put a bit of data in there, you don't want it just to sort of just have a giant bucket. You want to think, well, how am I going to organize it? So all these things come up very, very early on, and that's why we wanted to call it out, because we see working with our customers that they're like, cool, we've got our high level design, we've got our physical design now, and wanted to start build our data pipelines. And yeah, by focusing really early on having a really well designed and nice data lake, you're really setting yourself up for success for all future scenarios, or current and future scenarios. So yeah, very important concept.
Absolutely. And that also ensures that, you know, data warehouse, a modern data warehouse, a data lake that you are trying to build is not solving just requirements of just one group that I spoke about, that those group of consumers, right? Um, when you build data lake as part of your modern data warehouse, you start with the concepts of zones and stuff. It gives you scale. Now you know that, things that you could not possibly do with a traditional data warehouse, wherein, you know for example, keeping multiple copies of your data. Now cloud economics come into picture with your modern data warehouse, and with a cost efficient data lake, you have that capability where you can keep the data uh, in the shape and form that makes sense for those different consumer groups, right? Different set of users. It doesn't have to be just one copy of data anymore,
Absolutely,
right?
yeah. And we just had a question from Gaming Boy on YouTube, and respect Gaming Boy, there's a bit of a gamer here. So I see modern data warehouses as a solution-specific architecture. Correct me if I'm wrong. Great question. Um, how I understand the question is he's saying that um, an architecture for a modern data warehouse is going to be really specific to the scenario that it's addressing. If that's what you're asking, then yes, it is. Well, Nitin, what do you think?
Yeah, no, it is, I would say, both ways. It is, of course, since we spoke about requirements, you are, trying to solve specific requirements. So you do want to make it specific to requirements, but specific to a particular use case, I would say no, because like I said, there are different consumer groups, different users of this modern data warehouse, right? So uh, when we build modern data warehouse, it's not just for one business case. There could be, you're serving different business functions within your organizations. You're also serving the team that's going to work behind the scenes. For example, a recent discussion comes into my mind wherein uh, customer was trying to build solution as part of this data lake, where the access to this data in near real time becomes available to the data science team. And what they want to do is process this data and make it available as part of the source system itself, the CRM, where their sales teams are hooked into, right? So the insights that you can get out of this data, while the data is getting consumed for your business functions, for building the dashboards, etc., it can also go back to your source systems where a different set of users are glued in, and it can really bring that value. So I think kind of yes and no, if you know what I mean, right? So in all, a well designed um, and built data lake is going to be very important to your modern data warehousing project. And when I say project, it's important once again to focus on requirements, timelines, so that it doesn't remain as a project. It becomes a product. It starts serving data as a product, right? Which drives that culture in your organization. Um, Next, we do have these additional resources which we strongly recommend that you consume in your uh, time, in your at your own pace. Concepts like what is Delta Lake, what is a lake database or lake warehouse, or lake house as some people call it. More focus on Synapse analytics. I will give you a view of the learning path we have as part of the collection, but it is important to understand once you know the concepts, how you're going to implement those concepts, and that's where specifics of services, the platform come into picture. So do make use of these resources. Ask these questions to yourself, which will give you those requirements that you will make use of in building the solution. um, yeah, I think that's where we jump into building.
Great. I think that's a great way to finish, Nitin, on that subject. And yeah, please make use of all those additional resources that are contained in here and also the collection. So hopefully you can see my screen now. I'm operating on a single monitor at the moment, which is unexpected, but we're going to be talking about building, the second component of this presentation. So this initial bit, I'm going to go through quite quickly because I think we've covered a lot just through our discussion earlier, but just really hammer home some key takeaways. So don't attempt to boil the ocean when you're embarking on your modern data warehouse build, okay? I have worked with customers that have got, say, an existing on-prem data warehouse, and they look at it with maybe a bit of like disdain. Oh, it's old. Yeah, but it might be old, and it may not suit all the new and modern business requirements. But it may have taken 10 years to build, and it may be serving a lot of existing requirements. And so I have seen some organizations go, oh, we can just redo it. We'll just redo it all on our modern data warehouse. No, that is really not a good idea. So build based on business scenarios that you need to address. And so you might have one scenario to begin with, you might have 10. If you've got more than one, have a priority list and work through them. Another thing when you're building is to think about how we can provide value to the business fast. So traditional data warehouse projects actually had a pretty bad success rate for completion, because often they were like, got to buy hardware and build that model and build all your pipelines. It might take months, a year, or even multiple years before you can start delivering back to the business. That's good. So instead, as you're building it, make sure you're focusing on how can we show value to the business, because once you do that, they're like, hey, this is fantastic, we want more, and they just keep throwing more and more scenarios, and that's brilliant. Really key points. So make sure you have before you sort of even start building, make sure you've got the skill set within the team to support that build. It makes sense, but it is something that Nitin touched on earlier in the design phase, which is if you have got some really strong skills in, say, SQL, then you might want to lean into those technologies. But if you have chosen to, say, go with Spark, which is great, do you have the skill set to support that? Do you need to have it go in training? Just something that you need to think of before beginning. And again, we've mentioned this before, focus on getting that data lake right. And we actually have some really great documentation, in my opinion, on how to actually go about building this data lake. So as, that's looking a bit small, sorry about that. Oopsie, that's taking some. Okay, so as it's probably not still quite big enough, but anyway, we'll do our best. As we mentioned earlier, data lake is a concept. Okay, Azure Data Lake Storage Gen 2 is a service that you use to basically build it out. And so our guidance is we've actually got some really good guidance here. And so sometimes you might think, okay, I just need one ADLS Gen 2 account to support my data lake. I might actually need 3. Or maybe, can I go with, maybe I need 4. Maybe I need to have one that's actually kind of, I need to ingest some things from the internet, so that's going to be public facing. I might need to have some private ones. So this document called Data Lake Zones and Containers, really great reading there. And additionally, best practices. So who doesn't love best practices built on knowledge of working with lots of organizations? I wanted to call out some things that this document has got in here, because it's going to be something you straight away going to come in, need to think about. And that is, say, the file formats of your data. Okay, what are we going to go? We store the data in JSON, CSV, Parquet, whatever. You need to make that decision very early on, and we've got some great guidance here. Also about file sizes. Okay, so we've got some guidance that says, hey, for good performance, go from 256 megabytes up to 100 gigabytes in size. That's the Goldilocks zone. It's a huge, it's a huge range, but it gives you a starting point, and it tells you kind of why you might want to go with some larger files as opposed to smaller ones. Okay, so next part of building, something I think we want to really get across, is to use infrastructure as code, or IAC. So what is it? So if you're coming from a data background, and I'm sure we've got some people watching this that are DBAs or data engineers, and they're really, really strong in that space. But this infrastructure as code concept might be new to you. So, but it is like an extremely strong recommendation that you go with it. So what is infrastructure as code? Let's jump in and have a look at this docs article. It is a way of building an environment by declaring what it is that you want. So if I want to have a Azure Data Lake Gen 2 storage account deployed, okay, I just say, I want this storage account. I want it in this region. I want it in this resource group. I want to have these settings enabled. That's what I want. I declare what I want. You pass that template to Azure, and it will just make it so. Okay, that's the idea, that you define what you want your environment to be like in code, and you basically put it, then you deploy that template, and it makes it happen. So the reason why would you want to use this? Well, it means that your environment is actually in source control. Okay, It also supports collaboration. So I can have different people working in different parts of the environment, and it all gets merged into your source control. And a really big one for people in the data space is avoiding environment drift. So I'm sure everyone has worked somewhere where production is very different to your test environment, and very different to dev. And in many databases or data warehouses that I've seen the production environment becomes the source control. It is the source of truth. So when developers need to develop, they take a copy of that database and they bring it back down to dev, and it's gigantic, and they've got to strip all the data out, and it becomes a nightmare. If you embrace infrastructure as code and Dataops, which we'll talk about, you can actually eliminate that problem. That's the dream. And we don't have enough time to go into any more depth into this, but my colleagues within Fast Track for Azure have actually put a really great video together on this topic. So strongly recommend checking that out, and you can really hear from the experts on this subject.
That also reminds me about our FTA Learn channel. So, we have sessions like these quite often on various subjects, and you know, you might just want to hook into one of those. It's open to anyone, and like I said, various subjects. Um, sorry, just wanted to add that.
Yeah, no, that's great. Yeah, so that this video is actually produced from that content. So yeah, great resource. Thanks, Nitin. That's great. Okay, next topic for building. Okay, so we've talked about building based on scenarios, using infrastructure as code. Next thing is Dataops. Okay, this is basically DevOps but for data projects. Okay, so what is it? Would love to be able to talk for an hour and a half just in this topic, but I won't. We've actually got this fantastic docs article called Dataops for the Modern Data Warehouse. It couldn't be more applicable if I tried, to help you understand what it is. Okay, so the good thing is it's got this, the article itself is not that, it doesn't have all the detail in it, but what it does have is, if I scroll down towards the bottom here, and I can never find it. Okay, we have the whole thing is actually a solution in GitHub. So if you can follow that link, it will take you to GitHub, and you can actually grab that solution and try it out yourself. And additionally, the person who created this content has also kindly recorded it and made it available. So if you remember anything from this session, and if you hear the word Dataops, just remember that we've got documentation on it. Okay, we've got solutions in GitHub, and we've got even videos to talk you through it. So that's what it is. But why? Exactly the same reason as infrastructure as code for the data components. It's just sorry, I lost my train of thought, but it's just same reasons as infrastructure as code. And the challenge though with Dataops, I find, is that with a solution you might have multiple services. You might have a data factory, you might have a database, you might have Synapse, you might have Databricks, you might have lots of different things. So how do you use Dataops across all of those? Answer: it can be challenging. Okay, so I strongly recommend embracing it, especially where the Azure services just natively hook into it, things like Synapse and Data Factory. But at the same time, you don't need to get to Nirvana for your Dataops. Okay, you want to automate things to a point where it makes sense to put that investment in, and to get a fully automated process can actually be quite challenging. But if you get to sort of 70%, 80% of there, then you're going to set yourself up for success. And so the key thing is that, in my opinion, bringing these methodologies like agile methodologies and infrastructure as code and Dataops, it's the secret ingredient for the cloud. It's how you get the most out of it. We were having a discussion internally recently about should you do releases on a Friday night? And someone was like, no, you should never do a release on a Friday night because it's guaranteed to go wrong, ruin your whole weekend, and that's terrible. But if you have made that leap of faith, okay, and you embrace infrastructure as code and Dataops, okay, then you can deploy on Friday 5 times if you want. You can deploy as frequently as you want. And once you have confidence in that automation and those builds and releases, it is really a whole new world. So it's strongly recommended.
Yeah, and I might add, this also brings sort of documentation to your whole project, something which, as uh, I mean, I can talk about myself as a data person, not really good at. So when you have all this infrastructure as a code, when you have data ops set up, automatically you have some documentation in some shape and form, which makes it easier for uh, the stakeholders, for the uh, new person on the team to understand what we did, why we did that. Um, just to add.
What a great point. That's, yeah, in a small environment, okay, you might get away with managing your solution in the Azure portal. But once you reach a certain size, it actually becomes easier to do it through code. And as Nitin said, it becomes the documentation for your solution. So as long as you can sort of, understand ARM templates or read bicep or whatever, or Terraform, whatever you're using, it actually, yeah, it documents the environment, which is awesome. Yeah, so let's move on to the metadata driven. Okay, so a really common thing I see customers do is fire up, start the modern data warehouse project, create a data factory instance, or say you start using Synapse pipelines, and they go, okay, I've got 10 tables to copy. Okay, I'm going to create 10 pipelines, land it in my data lake. This is great. Then someone says, okay, we need another 100 tables, and they're like, what? That's 100 pipelines. Hang on, this isn't at scale. So very quickly they realize that you need to think about how to actually build these data pipelines, and to do that, to avoid having one pipeline per table, you can use parameterization and use metadata. So what we often see is that people go with lots and lots and lots and lots of these copy pipelines, and then they embrace metadata driven approach, and they end up with like one pipeline for all their copy activities. Well, maybe one pipeline for one's for SQL to data lake, one's for one is from like API to data lake, whatever, but a far fewer number. So we actually have a great article, surprise, surprise, on building large-scale data copy pipelines with metadata-driven approach in the copy tool. So thankfully, the product group has acknowledged that this is a challenge, and have put together basically a tool and this kind of wizard to help you build that out yourself. Last point for this one is to plan for failure and define steps to recover. So when you're building your ETL and ELT pipelines, you should always anticipate that one day they're going to fail at any point in that chain. So if you have like 10 steps in your in that process, you need to anticipate what would happen if it failed halfway through step 3, or halfway through at the end of step 7. Like, how do you even know that it failed? How do you detect that it failed? And most importantly, how do you recover? So if it's like a lot of data warehouses are built like on sort of like a truncate reload, and the process to recover is a bit clunky, but you basically just restart everything from the beginning, goes through. But if you have set it up to be doing like delta loads, and the data is gone through various zones, and it's maybe even appearing in Power BI reports, if the business says, hey, why are we seeing duplicate data from yesterday? Hopefully that doesn't happen because you've detected it earlier, but if it does happen, how do you unpick it? And it's really important to consider this as you're building. If you if you go to production and you haven't thought about this, it's quite hard to sort of to put it back into your solution afterwards. So that's what we wanted to cover on building. Nitin, do you have any other comments on that, or should we jump ahead and go to operating?
No, I think I just want to add a couple of things. One, we talked about metadata driven, we talked about Dataops, we did talk about infrastructure as a code, and um, you know, good to know fact is that the pipelines that you build either with Azure Data Factory or Synapse, uh, Synapse integration pipeline do have these capabilities inbuilt. So what I'm trying to really say is that while we're talking about the concepts, it's also equally, if not more important, to understand the services that we are going to use, which says, fair enough, we know that we are going to uh, make use of Dataops, but how do you really make it easier to use that? There is help available, right? Um, yeah, so I think that's my plugin, and we can move on to operating part. Now that you have built your data platform and reiterating, it's an iterative process. It's hopefully a modular design which you don't have to rebuild, but you can always add to in future. The next part is operating. Now that you have this uh, modern data warehouse, a data lake, or really a data platform available to serve those business requirements that you've identified, how do you operate it and make sure that you know it doesn't turn into something that's not giving you the right information, right? How do you avoid building a data swamp? So the answer to a lot of these questions is governance. Governance for data being the product of this platform that you are building, as well as governance of resources that you have in place for in this platform, right? So when you talk about data governance, what makes sense or what it really implies is how the data is going to get ingested, you know who will own data at which layer, right? you know who's going to have access to what piece of data to be able to process it, to be able to curate it, and then also the business which is going to look at the data, the process data that you have come up with, the information that you want to share back with business. Are they able to uh, you know do you want to make it capable enough so that they can serve their own needs, so make it self-serve capable, right? So this is really around data governance. If I talk about very briefly around Microsoft Purview, it's another component which has been tightly coupled with Synapse Analytics, but it it has capabilities of doing a lot of things, and primary focus is on governance, right? You you want to ensure that you know where the data is coming from, so you have a data catalog which is searchable. Let's say you're making self-serve capability possible with your platform, with your new modern data warehouse. So the end users, the business functions, the various groups of users who are going to consume data, are they able to identify where and how the data exists? How do they access this data? And you know that's really the gist of it. But I mean, obviously, I won't go into details of it because it's a rather big concept in itself, and a topic that will probably take a couple of hours in itself. But the idea is you're able to look at the data as it is, whether it is in your sources, it is in your data lake environment, it is across your data warehouse, the sensitivity of certain data, classification of your data, how you will access this data, who is um, allowed to access, who is that uh, data guardian or custodian of your data, and so on. So that's where data governance comes into picture. um, the
It's
next
a huge
part.
topic, isn't it?
Oh yes. Oh yes, I mean, purview itself is a large concept, a large service that does a lot of things. So obviously we cannot go into that, but the idea is with all this governance in place, you're trying to avoid building a data swamp, which really means that you will have data coming in a data swamp, but you don't know what is it that you are going to do with that, or who has worked with that data, or where does your you know for example curated data lie, and all of that, right?
When I first heard that term data swamp, I just thought, oh, if that's just someone made it up as a joke. But yeah, it is actually, a definition. If you look in the docs article, it's all in there. So yeah, don't build one.
Yeah, I mean, cannot be more right. The next one is obviously around platform governance. When you're building this platform on Azure, there are so many things that can help you, starting with Azure policy. If I just click that link and go through Azure policy, what all it talks about is really, how do you want to manage, who can manage this platform? That management plane of your platform is what this policy can define and sort of govern. So, for example, uh, a simple example could be who has capability to, let's say, resize a service queue. Let's say you have Azure SQL in the mix, right? Azure SQL DB. Now, is it possible for someone to, let's say, take it from 2 week course to 4 week course or not, right? That's something that you can govern using Azure policy. Then there is, you know, do you deny that, or do you log that and allow that, right? So a lot of these things which are part of Azure policy make it easy for you to put that governance around the platform, right? RBAC. RBAC is another very, very important piece of governance, I would say. Role-based access control is RBAC, right? So you ensure that uh, people who have been given certain roles are able to do certain things, right? And at a granular level. So, and when I talk about granular level, it is within a service as well as uh, within an within a resource group across services. Who can delete or who can create a new service? If they create, let's say, a new Cosmos DB environment, can they uh, you know take it to a certain SKU? Should they do it within this limitation? All of that goes into your Azure policy, and it's a great way of controlling you know what all you want people to be able to do. That ensures that you have governance, and uh, you don't end up with data being lost, services not functioning properly, and things like that, right? I think process is a part which we'll all agree. It's one of the most important things. Sometimes we think that processes put in place make things slow, but that may or may not be right, but it definitely is true that without process you are, well, if I choose my word wisely, you're at least not on the path to success, right? If you don't know uh, who's going to be the person that's or the role who's going to be able to manage certain thing, you don't know if you will be able to see your data once it has landed tomorrow or not, right? So any comments, Ben? I think.
Oh yeah, I just I think I'm very a big fan of like process light or light process, just just enough to keep things under control. And an Azure policy is a really great way of doing that. Like I think what people really love it for, it's like don't let developers deploy 128 vCore virtual machine in their own subscription and get a really big bill at the end of the month. Yeah, and don't let importantly, don't let people deploy things in regions that maybe are not approved inside the business. So I think just a combination of kind of the guardrails that Azure policy provides with light process around it, just to keep the lights on, keep everything running okay.
True. Next one is monitoring. Obviously, when you're operating, you do want to monitor. And do remember that with the change of platform, with the change of, you know, moving from traditional warehouses to modern data warehouse, or for that matter, any modern system, the requirements around monitoring do change, right? You are no longer just monitoring, say, the availability, right? You are also monitoring, you know, what is it, for example, very different concept, but how much is certain resource consuming over a period of time, right? So on one hand you have availability, you have uh, performance. On the other hand, when you have cloud economics, you also want to make sure that you know you're not spent $100,000 to start with this project, right? Maybe you started small, but monitoring also allows you, and it is inbuilt in almost all of the services, to see that if you have built a pipeline, how much is that pipeline going to cost you to run it once, to run it 100 times in a day. So monitoring all over, what I'm trying to say is that pay attention to your monitoring requirements. It's probably not the just the same as you had in your traditional environment.
Yeah, it's if you're if you're bringing an existing, if you're migrating from a data warehouse or something on-prem and you're coming into Azure, your requirements for monitoring will most likely change. A, because you're building a different solution, but B, you're using different technologies. And although it's not the exciting part, I would argue, of a one data warehouse project, you've got a bunch of data engineers and they just want to get in there and write SQL. If you go into, as don't need to really say this, but if you go into production and you haven't considered monitoring until you're in production, which we definitely have people do, it's really going to be a challenge to actually operate this solution.
Yeah, can't agree more. Um, okay, the final one on the operating part is optimization. Just like we talked about the design, optimization obviously is an iterative process. You never really have a fully optimized environment. The reason, your requirements are going to keep changing. Your, the volume of data is going to keep changing, right? So there, it will present you with more and more opportunities to keep working on that optimization. To whether it is optimization of performance, optimization of cost involved, of course, uh, all of which is very important because you have stakeholders involved, right? It's not just you in isolation building a data lake or a modern data warehouse and you know being happy with what you see in the data. If it's not performant enough for your end consumers and users, uh, there is there is a chance, there is a likely scenario that you know business doesn't see value in it. So what I'm trying to say is whether it is uh, an environment which you are not planning to change very often, but just sheer fact that the volume of data is going to change, and maybe you'll add another source of data into your platform, is going to require that you keep working on this optimization part for performance, as well as continue to having a cost efficient modern data warehouse and a data lake environment. Yeah, I think with that we can, um, in the interest of time, we can really move to the next one. Ben?
Thank you. Yeah, thanks, Nitin. That's great. And actually, optimization is really, especially the cost side. I think it's a really kind of fun thing for data engineers or people to start doing. Like if this is your first solution that you're managing in the cloud on Azure, it's something you probably didn't need to do on-prem. Like you deploy a VM and it just runs. But now it's like, cool, I can stop things, I can scale up, I can scale down, I can use serverless solutions, and really a whole new aspect of data DBA's role or a data engineer's role. So, yeah. Okay, so we've covered so far designing, building, and operating. We did and R about security and whether we should weave it in throughout those first three topics or have its own section. So we decided to have its own section. We have mentioned it a few times, but take a deep breath because there is a lot. That deep breath is for myself actually, but there is a lot to cover under security. Okay, and we are pretty limited on time, so I can tell you right now we're not going to cover everything. But again, that was kind of the point of putting this together, is that we wouldn't talk to everything, but you've got this as a resource. So let me jump into it. Security, it's really, really, really important. Okay, that's the end. No, it's something that you need to build into. You need to design. Okay, when you're at the design phase, you need to be thinking about security. When you're in the build phase, you need to be thinking about security, and the operate, thinking about it too. I wanted to call out that it's your strategy for approaching it is defense in depth. By that I mean like multi-layer defense, like utilizing lots of different things to secure your environment. Also, I want you to consider to make sure you understand the concept of zero trust. Okay, so Azure was built around this concept where every service that we built, like storage and Azure SQL, would be secure in themselves. So like Azure SQL database has got its own firewall, storage accounts have got their own firewall, you authenticate to them, and so basically they're kind of like their own little island with their own protection. So get your head around the concept of zero trust, and importantly, and that will especially become clear when we talk about network security, which we'll talk about just in a moment. So consider if you need to set up auditing, like how you want to audit access to this data. So eventually this modern data warehouse is going to have potentially huge volume of data and potentially sensitive information. So how do you protect it? Okay, well, one thing you can do is set up auditing, like who's accessing the data. Okay, you can also set up just detect who's accessing and alert on that. And the tools we use for that are Azure Monitor, Microsoft Defender for Cloud, and Sentinel. And I think we've got three different sessions that you can you can listen to on those three topics. Next point is enable, like where services have got special features like Azure SQL, like security features, turn them on, like advanced threat protection. If you put that on for, say, Azure SQL, it will do things like detect SQL injection attacks. It will detect if somebody's logging in from an unknown location, which I get alerts for all the time when I log in from a coffee shop and it's a new IP address, and I get an email saying, hey, someone's doing something weird. So turn that on. Really, I want to call it data exfiltration, because that's what hackers are trying to basically do. It's like one thing is that they want to get into your environment, but it's not just for fun. They want to do it so they can get access to your data and get it out. So when you're designing your solution, make sure you're considering that threat and how you can protect against data exfiltration. We actually have got some great documentation on this. So we've got something on Synapse Analytics, okay, and it's about securing data egress, which means data leaving from Synapse workspaces. So definitely make sure you consider that. And the next 2 points, I just want to say on encryption that communication between all services within Azure utilizes encryption. And all services, I think, that store data support encryption as well for data, so the encryption at rest. And you can use like Microsoft keys or bring your own as well. So basically, lots of different components to protecting a solution. Have I missed anything, Nitin? Is there anything else you'd want to call out for defense in
No, I
depth?
think it's I just want to call out that, all of this and a lot of this information is already here. In the interest of time, we will obviously not go into details of all of these components because obviously, this in itself might require a few hours of time. But it's, really important that you do make yourself familiar with the options that you have. Like I started by saying, platform is only as compliant as you make it.
Great point. Yeah. Great point. And it like Azure provides all these services and all these features to help secure your environment, but the responsibility is really on yourselves to implement them and make sure you've done it correctly. So let's move on. The next thing we want to talk about is credential management. So again, a huge topic, but when you're building out your solutions, I strongly recommend using managed identities. So what that means is if I deploy Data Factory, okay, it's going to be assigned an identity, an AAD identity, okay, that you don't have access to. You don't know the password, okay, but it can then use that itself to authenticate to other services like the storage account or to SQL. So the instance of your Data Factory instance itself has, basically does its own authenticate. The beauty of that is that you don't need to worry about storing username and passwords, right? But some data sources will need username and password if you're connecting to some really ancient old database that maybe it's not, definitely won't support AAD then. In which case, make sure you use Key Vault to protect those credentials. I've seen many times where customers are we're talking through some technical aspect of a data pipeline and they're sharing their screen, and then I go, oh, why have you just got the username and password just stored in the pipeline itself? Where's Key Vault? And they, oh, we'll do that later. Do it up front, deploy Key Vault as part of your solution up front, and make sure you store the credentials in there. So this leads on to the next point on network security. So network security is really, really important. I would say that I do see an overemphasis on network security in this kind of defense in depth discussion, where we see people coming from on-prem, maybe going with an armadillo approach, which is like really hard perimeter on the outside, soft and squishy in the middle, and they try to bring that into Azure. Okay, that's it's want you to have network security and definitely utilize it, but it's not the be all and end all. People's private networks do get attacked. So kind of going into Azure, we have a strong emphasis on identity and making identity as a real cornerstone for your security. So that means you're using things like Key Vault. It means really protecting those identities. So going back to this credential management bit, making sure that those identities have got things like multi-factor authentication enabled on them. You can use things like conditional access, and even use secured devices, like dedicated devices where people log into and to do the administration. So again, all of those things add up. So on network security, I want to call this out. I do see modern data warehouse projects fall into this trap sometimes, where they got the high level design, we've helped them develop their detailed design, okay, and they make an assumption that, oh, we can just use, say, like public endpoints. Okay, so cool, everything's talking on public endpoints, that's all good. But then they're about to deploy into production, and then security review the change, and they just say, nope, you've got to go private. So that's fine, but don't leave that discussion with the security team to the end, because it can actually change how you architect the solution. You might need additional components. There are a few Azure services that do not support private endpoints currently, so that will obviously change in time, but just something I really want to call out to do. Okay, we're getting super short on time. We've got 10 minutes left, I can see. I'm going to just really quickly talk about control plane versus data plane from a security perspective. So control plane, you can sort of think of it, everything you can sort of see in Azure and Azure portal. Like I can give access to a storage account. I can give someone permission to, say, like data blob reader on a storage account on AWS Gen 2, and then they can read all the data in the storage account. You generally probably don't want to give that such a high level of permission on a data lake. So then we would go down into the data plane. Okay, for data lake specifically, we use POSIX ACLs. I really love this series of acronyms, and we spelled it out there. But it's basically like saying, if you're familiar with Windows, okay, I want to set permissions on a folder, and any object that gets created in that will pick up those permissions. So that's very, very quick high level view of control plane and plane. Yeah, I'm going to have to just leave it at this. Last thing, just to call out, is Microsoft Defender for Cloud. It used to be called Azure Security Center. It's just had a recent name change. Okay, if you're a data engineer, you may not be familiar with the whole security world, and I put myself into that camp too. But a minimum key takeaway is go into your Azure environment, go into Microsoft Defender for Cloud, and go to your security posture, and there you'll see what's called a secure score. It's basically saying, hey, where you assess your environment based on rules, that here's score. Okay, and if you click on that, it'll say, okay, well, here's a breakdown of all the things you could do to improve your score. And that's what I want to see people getting there. Even at a minimum, get it on a weekly basis or a monthly basis to check your score, to check that any rules and ensure your environment is secure. It's like a free security consultant can use some advice across your environment. Really, really, really valuable.
Yeah, couldn't agree more.
Okay, so that's we had. Nitin, can you some struggling with my screen? Can you bring up the PowerPoint and just bring up this summary?
I'll just give a quick walkthrough of the collection that we have in place.
Oh yes, sorry. Yes,
it will just take a minute. So this is what you see, as the action point. And what we have done is we have put a few links here for you to consume, starting with the learning path. So we did talk about a lot of concepts, things that you keep in mind while building this solution, this data platform. But this learning path specifically talks about how you do that on Azure, right? For example, Ben spoke about skills and things around that you need to keep in mind. Now, this one takes you across those capabilities that the platform has, how you can make use of those things, how you can secure that, how you can design it properly. If you want to do work with Spark environment, how you can possibly do data flows to make sure that you have Spark working for you, but you don't have to write a whole lot of code and things like that. So quite comprehensive. We strongly recommend that you follow through at your own pace, but do go through this in detail. As the next one, this is a link to the repo that Ben and I have been, uh, you know, taking you through. So
Yep.
really everything that we have talked about is there, and we'll keep updating it as we go. The next one are few architecture documents which talk about all the possible, you know, Synapse Analytics use cases and specific to small and medium businesses. So, there are capabilities in Synapse Analytics, for example, to do pipelines, to do, Data Explorer and things like that. Just so that you are aware, do go through this. You will identify some of these ways that you want to build your data platform in, build your modern data warehouse in. Next, very quickly, there are a couple of tricks or features that possibly make it easier for you to, work with the data platform. So if you do use this NoSQL database called Azure Cosmos database, we came up with Synapse Link, which allows you to get rid of all the ETL pipeline that you need to build before you can consume this data in an analytical store. So that's what this links talks about. Um, and then, there are other reference pages that, again, as part of the team, as part of this engagement that we have with fast track engagements that we have with other customers, the team has put across these really recommended points that we should, you know, uh, look at and ensure that, uh, you have the good understanding. Next, I hope you're able to see the summary slide. Ben, can you confirm?
Yes. Yeah, to my producer, I'm not sure which screen it's on, but I'm going to talk through it quickly because we're almost out of time. So number one, don't stop here. I think we've mentioned it about 100 times, but access our collection that we put together. Okay, it's really, really great, in my opinion. Number two, build a modern data warehouse to match your modern business requirements and scenarios. Three, produce a high level and detailed design or multiple detailed designs with a reference architecture as a starting point. Number four, requirements, requirements, requirements. Make sure you're not just building a generic data platform. Make sure you're building it for the business, for specific requirements. Key takeaway number five is initially focus on designing and building your data lake. Six, build solution using infrastructure as code and Dataops. Seven, operationalize your solution with governance, monitoring, and optimization. And finally, design and build security into the solution from the very beginning, considering concepts such as zero trust and defense in depth. Don't do it the same as don't do security exactly the same as you've done on-prem. Okay, and don't forget to protect those precious identities.
Yes, very important. And uh, I
So,
think with
and
that,
again, sorry, Nathan, did go on?
I was just saying that with that, we really hope that you found this conversation or a session helpful. Um for your consumption, this is the link again where you can, you know, get to the collections that we spoke about. Um, land there and go through the whole content that we spoke about.
Absolutely. And again, just want to say, I just want to again thank you for your time for watching live or watching the recording. I'm Ben Harding, and it's been a pleasure presenting to you. I'm going to call out, just don't miss our next upcoming session. So all the details should be on your screen right now, and the links to go and watch about, go and learn about Azure Cosmos DB and how to design and implement for SQL API.
Yep, and hope to see you there in the next session as well. Um, have a good day. Been a fun session. Really enjoyed doing this. Thank you. Thanks for your time.
Thanks all.